This is Prateek Joshi, Senior Software Engineer at Shorthills AI. Welcome to this short tutorial on comparison of vector databases. Today we will be comparing different vector databases on several factors such as searching, cost-effective factors, etc. Vector databases hold a very crucial factor when it comes to building RAG pipelines or creating vector embedding.
Today we will be comparing different vector databases on several kinds of factors. Since vector databases are tailored for different kinds of purposes and use cases, we'll be comparing these vector databases to find the right vector database for our use case. So we have 4 different vector databases for comparison. We will be comparing VB8, pgvector, Milvus, and Quadrant. Before we get into comparing these vector databases, we should also understand on how a vector database can be used for our use cases. So the steps for utilizing a vector databases are: first step is to creating a container for the vector database server. This can be done by using tools like Docker and creating a container for our vector database server. The second step is connecting the application with the database. The steps for these can be easily available on the documentation of the vector database. The third step is creating or using a database collection. A collection is a very important part of a vector database. A collection is often used to then be creating embeddings for our different text. The fourth step is creating vector embeddings using an embedding model. Choosing the right embedding model is a very important step before choosing a vector database. We will be comparing a few embedding models after this. The last step is performing the vector or hybrid search. Not all vector databases support hybrid search, so it is important to compare and understand which vector database should we choose for hybrid search support or not. So the first vector database that we have is Milvus. Milvus is an open source vector database that has high performance and is optimized for large scale vector search. It comes with Apache 2.0 license and has the support for BM25 and sparse search. BM25 is a hybrid search which allows the vector database to be able to perform keyword along with vector search. Geospatial search is not supported in Milvus. However, if we talk about pgvector, which is another vector database offered by PostgreSQL, so this kind of vector database is normally used for those cases where PostgreSQL is already integrated with the systems. PostgreSQL vector database comes with PostgreSQL license and has a support for all searches, BM25, sparse, and geospatial. VB8 is another open source vector database that has the support for BM25 and geospatial search. However, it comes with BSD license, which has its own limitations. It focuses on integrating vector data with rich contextual metadata. This provides flexibility to be able to use that metadata whenever our match is found and to be able to use that data for our own needs. The last vector database is Quadrant. Quadrant is a vector similarity search engine that provides easy production-ready services with convenient API for usage. So Quadrant has support for BM25. Quadrant has the support for sparse and geospatial search. However, it does not have the support for BM25 or hybrid search. This is one of the limitations of Quadrant, that hybrid search is not supported in this, due to which, however, sparse search and geospatial search are widely used with Quadrant. Quadrant comes with Apache 2.0 license, which is widely accepted. There are a few factors as well apart from search that need to be considered while using a vector database. One of those factors is scalability and latency. Scalability and latency are very crucial when we are comparing vector databases, as a few vector databases like PG vector may not be a very good choice if we are talking about scalability. Milvus and VV8, however, offer very good scalability. They are uh, they are specifically considered for high performance use cases. Milvus is ideal for applications requiring high performance vectors search, specifically for image recognition, recommendation systems, and NLP tasks. It supports vector search, sparse search, and geospatial search. VV8 is best suited for semantic search and for recommendation engines and hybrid search capabilities. It integrates vector data with rich contextual metadata and supports geospatial search. If we talk about the licensing that we had previously compared, Milvus and Quadrant come with Apache 2.0 license, which is widely accepted and provides a high level of flexibility. VV8 comes with a BSD license and has offering permissive issues and modification rights. EG Vector comes with PostgreSQL license, which is appropriate for projects already integrated with PostgreSQL. If we have the comparison table, if we see the comparison table, so we can see that most of these vector databases have some of the searches that are not supported. However, PG Vector has the support for all of these searches, but if we talk about scalability, PG Vector might not be a very good choice. However, in today's date, SQL databases are also scalable and can also be used even if scalability is a concern. In conclusion, one has to be aware about the use cases that they want to support and the type of problem that they are addressing by using the vector database. So if we talk about Milvus or Quadrant, so it could be a strong candidate for high performance and scalable vector search. On the contrary, VV8 offers a very robust solution for AI-driven applications involving semantic search. PG Vector, on the other hand, is best suited for integrating vector search into existing PostgreSQL environment, but may have limitations in scalability. Hence, choosing the right vector database is not just about choosing, comparing these factors, but however, understanding the use cases that one has to cater. Now, let's compare some embedding models as we had previously understood. So, we have different kinds of embedding models that one has to compare in order to be able to create embeddings. So, if we talk about OpenAI, there are some kind of embedding models that OpenAI offers. So, embeddings, this is the section which provides the different kinds of embedding models that OpenAI performs. So, text embedding 3 large, text embedding 3 small, and text embedding ADA 002. So these are the different embedding models that OpenAI offers. However, when we talk about embedding models, it is crucial to compare the dimensions of these models. Based on the dimension, only then should one be choosing the right embedding model. And such models can only be used for those embeddings. Apart from OpenAI, Hugging Face also offers some kind of a lot of open source embedding models. So one of those embedding models is BG Large. So BG Large is an open source embedding model that is offered by Hugging Face, and there are other models as well of BG, such as BG Base, BG Small. But however, as we had previously discussed, the dimension is a very crucial factor for comparison of these embedding models. The higher the dimension, the larger the model would be. So if you see over here, there are also other factors for comparison, and all of these can be used for comparing and finalizing on which embedding model one should use. These are mostly high models, big models, under the BG section. However, if we talk about GT models, which are general text embeddings, so we have different kinds of models under these as well. GT large, GT base, GT small, these are one of the most popular models that are used. However, if you see the dimension comparison, GT large comes with 1024 dimension, GT base comes with 768, and GT small with 384. So in the end, one should understand that embedding models, uh, choosing embedding models has a crucial comparison factor for dimensions. So now we will be comparing VV8 and coordinate vector databases, and be looking into the code on how we can be able to perform different kinds of actions, such as loading the connection, deleting collections, inserting, and querying against these embeddings. So the init method, which initializes this class VB client manager, takes in few parameters like DB client name, the name of the collection, and the embedding model. The load collection method is used for loading the collection by using the collections.get method, but the delete collection method is used for deleting it. The load collection method creates the collection if the collection name is not found in the vector database. The insert method is used for inserting the embeddings into our vector database. It takes in the different parameters like properties, vector, and UUID. Properties is the metadata that we want to save against each embedding, and so that we can retrieve them and use them whenever we require. Vector is the encoded value of the query that we initially have to be saved into the embeddings. UUID is a unique identifier against each embedding and is recommended to be used over here. VV8 offers the flexibility to be able to perform hybrid search. So for that purpose, VV8 offers two methods, BM25 and the hybrid method. So if we talk about the hybrid method, it accepts the query. So basically, we want to query and be able to fetch some results corresponding to it. So the initial query is also required to be encoded. It is of string format initially, but once we encode it, we can be able to send it to our hybrid method. We also have an important parameter called alpha over here, which is used for giving weightage to keyword and vector search. We have the flexibility to be able to give higher weightage to keyword or vector search based on the value of alpha. Limit is one more parameter that is used for further only getting the top 10 or top 3 values or any kind of top k values from our list that we have obtained from the hybrid search. These results, the list of results that we obtain, are sorted in the descending order based on their similarity score values. The higher the similarity score, the better it is recommended that the query has a higher match against that embedding. So to further get more better values, we can use a threshold parameter as well. So this threshold parameter can be used to be able to get only those values having higher value of similarity scores more than this threshold value. We've used a prepare response method for this purpose that takes the threshold, calculates the original score from the metadata that we have already saved in the properties variable, and we obtain those properties, and based on that we are iterating and checking if the original score is greater than the threshold, and only appending those values for our final match. If we compare it with our quadrant vector database, the quadrant vector database also has a similar structure. So for that, we have used again DB client, the name of the collection, and the embedding. And we have the load collection method that is used for loading the collection or creating it if it does not exist. So if you see over here, if the collection does not exist for quadrant, it throws an exception. So we catch that exception and we create the collection against it. And if we still have an issue, we further raise an exception that we could not create a collection. The delete collection method is used for deleting the same collection. And then we have the insert method. So we have the db_client.upsert method of quadrant that is used for creating the embeddings. It requires the collection name and ID or the UUID, the vector as encoded value, and the payload again saved as metadata against each embedding. Then we have the query method. However, Quadrant does not have the support for hybrid search. So this query method takes in the query as string, the top k as the value that we want as to get the top k values from the final list of the search, and the threshold above which we want all our original score values to be obtained from. So the Q vector is basically the encoded value of our initial query, and the results is basically obtained from the db_client.search method of Quadrant. The collection name is again saved in our class name itself, and further we use the top k value to be able to get the top k values for those search results. We have similarly done the threshold usage that we had done for VV8 in Quadrant as well. However, the difference over here is that we do not have to calculate a original score like we had done for VV8. So in the end, we will conclude this video over here by again saying that vector database comparison is always never a few parameters only for comparison. It may be requiring our use case requirements. For example, if our use case requires hybrid searching, then Quadrant might not be a very good choice. However, if we want production readiness and easy usage, Quadrant might be a very good choice in that case. So it all depends on our use cases and different kinds of parameter comparisons to be able to finalize and choose the right vector database.
Hope you have liked this video. Feel free to add any questions in the comment section below. Thank you.